Hi there, fellow truth seekers. As I'm sure you're aware, one of the fundamental aspects for truth seekers to be concerned about is health. If you haven't got a working bodily unit, if your vehicle's broken, your life experience is necessarily compromised. It's obvious. But there's a lot of disinformation around health, and there are some fundamentals that are evaded routinely by the mainstream. And I wanted to share with you a series of videos which help to illustrate the importance of metabolic flexibility, the ability to burn fat and carbohydrates as fuel, the ability to effectively utilize ketones and glycogen. And there are considerable benefits as we get our body flexible to use both fuels and indeed burn ketones from the consumption of dietary fats, and particularly saturated fats, and particularly animal saturated fats. So to start off this series of videos, I want to show you this one by it's a lecture by Ron Rosedale, and he provides some very important background contextual information from our evolutionary past on why it is that dietary fats are so important. Enjoy.
Thank you for coming. Just by way of a very brief introduction, in the low-carb circles, I'm kind of the last original man standing. There were several people espousing a low-carb diet 20 years ago. I'm one of them. Most were correlating it with a high-protein diet, and I'm glad to see that I've convinced people that's not the case, or that shouldn't be the case. I was also the first person to connect leptin to diet and health. And then mTOR. I've fought against cholesterol being a villain for 20 years. And it might be new to you now, but you'll soon be hearing about not taking calcium, because taking calcium is quite detrimental to health and increases mortality and does not increase strong bones. And I've talked about that on National Public Radio for 20 years. And there's a reason. Not because I'm a genius, but because 20 years ago, I recognized that it was much more important to look at the commonalities among life and treat those commonalities if they were going wrong. I looked at the pathway that we took to life to know what is vital to life. And if something was out of whack, then that needed to be looked at. So let's go on a little bit of a journey for just a short while. I don't have very long. And so in, 15 minutes or so, we're going to tell you everything you need to know about nutrition, the formation of life, and medicine. About 4 billion years ago, life formed in the oceans. It's the prevailing view. Could have come from another planet where the same scenario might have taken place. Fatty acids coalesced like bubbles, and they formed around amino acids. And we had primitive cells that ultimately were able to divide into two and learned how to reproduce. And at that point then, it was a numbers game. Cholesterol at this point was vital right from the start because it helped in the rigidity of cell membranes. Otherwise, they would break apart too rapidly. That tells you one thing, that cholesterol cannot be the villain it's being made out to be, since it is common to every cell on Earth. You get rid of cholesterol, you get rid of life. That told me way back that we should not be taking statin cholesterol-lowering drugs. They cannot be good for you and will increase mortality, and that has shown now over and over and over again. They failed to tell you that. It became a numbers game. Those organisms that could reproduce the fastest were those most likely to survive. And at that point, glucose was the dominant fuel. It's a very simple molecule, and you can burn it without oxygen. There was no oxygen in the atmosphere at that point. Fat could not be used as a fuel, fatty acids. Good thing, didn't have to eat its own membrane, which delineated it from the world and kept its separateness. But you cannot burn fat without oxygen, but it's very easy to burn glucose without oxygen. That's really important, that fact. So we know that glucose was used as a fuel for billions of years before fat could be used. There had to be nutrient sensors that formed that told cells when to start reproducing, when fuel was available, meaning glucose. So when glucose was dominant and there was a lot of glucose, cells said, let's go, let's make hay while the getting's good. And they would reproduce as fast as possible. Those are our ancestors. Okay? We still have that genetic heritage in us. And when those signals come forth, when glucose is very available, and nutrient sensors, such as insulin, start telling the cells to start reproducing as fast as they can, we end up calling it cancer. Okay? Cancer is a default condition. It has to constantly be kept in check, dependent on nutrient availability. Cells formed colonies because in unity there is strength. There's a physical limit to how big cells can form, and so to get bigger, there were colonies of cells. Okay? That required then extracellular communication. There had to be communication among the parts to tell the parts what to do for the common good. Forming colonies was really smart for two reasons. Because by this point, there were plants, single-cell plants that were putting out oxygen. Oxygen was not the life-giving chemical that it's made out to be right now. It was likely the very first weapon of mass destruction. It was theorized that it destroyed at least 90% of life on Earth. It oxidized, and the poor ancient life had no means of antioxidation. Oxygen burns, and it virtually burned up almost all life. So cells would huddle together, and those that could be more resistant to oxygen were on the outside, and those that were more sensitive were on the inside. And we got sort of a division of labor. Antioxidant systems were built up, and especially mitochondria, which was a type of bacteria, learned how to use oxygen to burn food rather than burn itself. Symbiosis took place where a mother kind of ate a mitochondria and learned that they could cooperate together and use that mitochondria to generate energy from food while at the same time protect itself from the damage of oxygen. And it, in turn, would supply the mitochondria with food substrates to use. That division of labor was really important because another division of labor came forth. There had to be a means of documenting what was good and what worked and what wasn't. So genetic apparatus came along very early in the ballgame. At first, it was probably some sort of informational protein molecule. Then it's probably acknowledged that it was RNA. Later, morphed into DNA. So we had then a division between the important informational molecules that tell how to make and maintain life, called the germ cells, or the germ line, and the soma, the body, that took care of the germ cells. Okay? We still have that division of labor. It is the most important division of labor that there is. Why? Because that is why we age. That is why we die. Okay, early on, when you were just single-cell bacteria dividing and dividing and dividing, a numbers game, there really was no death. They just kept dividing. There's no corpse. Maybe occasionally from accident if you stepped on it, but not through disease as such. However, with the advent of the division of labor between the genome and the soma's purpose now was to protect that genome. It's the temporary caretaker. It's supposed to handle that baton and run with it to the next soma. Protect it, be its shield, and take the environmental hits, and then pass it on, tired and spent, to the next soma to do the same thing in a perpetual relay race, and then get off the track and die. This is what nature wants, and this is nature's purpose, and it is very important to understand that the soma, that you think of yourself as yourself, the body, is there to protect the genome, and all nature cares about is that we can protect that genome enough to get it to the next generation and allow the progeny to stand on its own 2 feet. And then nature does not care about us, and it allows us to die because we've fulfilled our purpose and have no more purpose. So, when you hear, let's just do what's natural, doing what's natural is making a baby, making sure that it can walk and eat, and then dying. Post-reproductive lifespan is irrelevant to nature, with that exception. So what we're trying to do, at least if you're my age and post-reproductively, and you are trying to live as long and as healthy a life as possible, that is not natural. We are trying to do what is not natural. And the only way that we can accomplish that, the only way we can really make headway into the chronic diseases of aging, is to learn how nature has endowed us with tricks so as to at least get to reproductive age, and it has. We know now that there is a common genetic pathway that virtually all life has, and especially all animal life. And it can be turned on or it can be turned off. And it's regulated by nutrient-sensing hormones that correlate nutrient availability with reproduction. In the ancient ocean, I told you that was one very important fact, and that was that glucose was the dominant fuel, and these rules were set up when glucose was the dominant fuel and not fat. Fat came later. Fat didn't come until mitochondria became incorporated in other cells, because mitochondria are the only organs that can burn fat because it can use oxygen. So, you have insulin, that is the major nutrient sensor of glucose. You've got mammalian target of rapamycin, which is a metabolic pathway that is a nutrient sensor for protein, and you've got leptin, which is the nutrient sensor for fat. The two main building blocks of life early on that were required to build any life contain nutrients were glucose as a fuel and proteins. And so the nutrients that regulate all nutrient sensors, that then regulate a genetic pathway of longevity, are insulin and mTOR. The nutrients being glucose and protein. Leptin came later, and is probably the most important one in humans. But and I get arguments with people all the time on various blogs that tell me, oh, leptin is just regulated by how much fat you have. That's false. It's regulated by every meal. You can double your leptin levels in 12 hours if you eat a high carbohydrate meal. And it is those spikes in leptin and spikes in insulin that cause insulin and leptin resistance, so that then you have a miscommunication. So just like communication was required for life to form when you had multi-celled colonies, miscommunication is the cause of all disease. There is no exception to that. It is the communication you have to deal with when you're trying to treat somebody. Diabetes is not a disease of blood sugar. It's a disease of miscommunication of insulin and leptin. Sugar is just listening to the orders. Medicine just treats glucose. Lowers glucose, to hell with insulin. And almost always insulin goes up and people die faster. That was seen in the Accord study, if you want to look that up. And they were puzzled. How could that be? They took more medicine and they had better glucose control, and yet they had a much higher mortality rate. That was because they were raising insulin. Same thing with leptin. We are not our genes. We are the music that our genes play. Genetic expression. Meals regulate genetic expression more than anything. Food does. The breakfast I ate this morning will change at least 8,000 genes. I've got maybe 13,000. The difference between a man and a woman is about 200 genes. Okay. You can take a piano of 84 keys or so, and how many different songs can you play? An almost infinite variety. You can take your same genes and you can play the music of diabetes, or you can play the music of a long life and healthy life. It will be determined by what you eat, because what you eat regulates nutrient sensors, insulin, mTOR, and leptin, that regulate a longevity pathway. And when they were all kept low, which fools your body into believing that you are experiencing a famine, it upregulates repair mechanisms, DNA repair, intracellular antioxidant systems, autophagy, which is kind of a cellular garbage collection, heat shock proteins, all sorts of things that will allow you to stay healthy and outlive the famine so that you can reproduce at a future, more opportune time. And we can keep those things going post-reproduction if we keep insulin, mTOR, and leptin down. And the only way to do that is to keep glucose down and to keep protein down. Fat is a free fuel. It's not really involved in regulating the nutrient sensors. That's interesting. In other words, you can make your body believe that you are experiencing a famine and get all the benefits of fasting, get all the benefits of caloric restriction, but you don't have to do it. Just eat a lot of fat. And you get the same benefits, and I wrote a paper on that. It's published. And it is the way to go. Any questions? I think I have about, 2 minutes?
Use the mics on either side.
Ask you, what is your position on fiber and sort of excess fiber versus moderate amount?
Sure. Fiber. Fiber is either soluble or insoluble. Okay. Soluble is a fiber that can only be digested by bacteria into short and medium chain fatty acids. Okay. So it's fine. It's good. Fills you up, makes you believe that you've eaten something, and you actually are going to end up eating fat. Insoluble fiber is just like eating nothing. It just goes in and out of you. It's essentially a non-factor. You might say that it helps scrub out the intestines a little bit, so it might have a little bit of benefit. But for the most part, it's no more than that. Another question?
Dr. Kresser mentioned yesterday in the debate that you had that the evolution of the brain was from carbohydrates.
Well, he's totally wrong on that. A lot of things that you hear are just, I don't know where they get these things. It could not have been that way. Impossible. Because we know that our brain consumes a lot of energy. A newborn consumes almost 70% of the energy requirements of that body. Okay. The only way that the brain even currently can operate properly, but especially could evolve into a larger brain, was to start eating a more nutrient-dense food. Because you can only utilize fuel that has energy over and above what you're going to expend to get it. So you have to expend a lot of energy to hunt and gather vegetables. You don't have a lot left over. And they've shown that our mouth became smaller and our intestines shortened because our intestines are also an expensive tissue, uses a lot of energy. So we had to use less energy in our intestines so that we could put more energy into our brain. And the only way to do that is that if we evolved into eating a higher fat diet. This is called the expensive tissue hypothesis. It's widely accepted in paleoanthropology, and many other papers now have come out in support of that. And so that was wrong. The safe starch debate, if I had more time, really boils down to, we know that glucose is maintained up until death. You can starve yourself and your glucose will maintain. There is no such thing as a glucose deficiency. That's wrong. All you can say is, they might say, is that it's more advantageous to eat glucose than to have your body make it. That's what they might say. That's all they could correctly argue. But that's wrong, because you will never know exactly when and where and how you will need that glucose. Your body will make it when it needs it and where it needs it. And let your body do its thing. It's also when you eat it, you have adverse effects that take place, such as it will raise your insulin, it will raise your leptin, you will shut off your maintenance and repair mechanisms, that pathway we just talked about. You want to keep them low, and by eating the glucose, you can't keep them low. So there's an adverse effect from eating it as opposed to the gluconeogenesis. Furthermore, with gluconeogenesis, the substrates matter. In other words, if you are making the glucose from amino acids, that is not good. That's why I've always recommended a lower protein diet, because I don't want you to burn protein for fuel. All food can be used either to supply the parts that you need or to burn for fuel. You want protein to supply the parts. You don't want it to burn for fuel. To burn protein for fuel, you have to deaminate it, take off the nitrogen, make urea and ammonia, which is a poison that your kidneys then have to get rid of. Okay. So we do not want to use protein as a substrate to make glucose, but we don't have to. On a high-fat diet, you use the fat to make glucose. The glycerol, you can make glucose. The ketones, well, your body preferentially burns ketones, and many studies show that ketones are a much healthier fuel for nerves and your brain and almost every other tissue, including your heart, which will pump harder on ketones than it will on glucose. Okay. So between the ketones, between the glucose manufactured from the glycerol, between recycled lactate and pyruvate, you can supply all of your glucose needs. You know, they keep saying, well, glucose is necessary for glycoproteins, blah, blah, blah. Nobody's arguing that. We know that glucose is necessary, okay? But it's not necessary to eat it. In fact, it's very disadvantageous to eat it. Your body can make what it wants, when it wants, and it can make it through an easier mechanism, a more efficient mechanism that is a healthier mechanism, i.e. through ketones. Okay, thank you.
Thank you.